30,000 tons of glass, 2,000-degree heat, and zero impact crater. That is the physical impossibility we are analyzing today.
So, just try to picture this. Across 6,500 square kilometers of the Great Sand Sea, an enormous amount of high-purity silica glass just litters the desert floor. And the heat needed to do this? To literally fuse desert sand into what we now call Libyan desert glass? We're talking temperatures hotter than most volcanic lava.
And yet, for about a century, the most obvious explanation, a meteorite slamming into the Earth, has been argued about, all because there's a complete absence of a crater.
So, to get around this paradox, the prevailing theory was a massive atmospheric airburst. Basically, a giant explosion high up in the sky that melted the sand below.
Now, an airburst sounds plausible, right? It would explain the intense heat and the missing crater. Seemed like a neat, tidy solution. But then, a 2019 study from Curtin University came along and found a fatal flaw. A piece of evidence the theory just couldn't explain.
Yeah, this flaw, it isn't about the heat. It's all about pressure. And we're not talking about a small difference here. It's a million-fold gap between the airburst theory and the physical evidence that's literally locked inside the glass.
The evidence right there, inside the glass itself, shows it was hit with at least 30 gigapascals of pressure. Now, to put that into perspective, that's over 4 million pounds per square inch. That is a force that you just can't get from an explosion in the sky.
Exactly. An airburst creates what's called atmospheric overpressure, and you measure that in thousands of pascals. But the glass, it recorded pressure in the billions of pascals. This isn't just a minor detail. We're talking about completely different orders of magnitude. The data here is absolutely clear. An airburst is not physically capable of doing this. The laws of physics just don't allow it. Only a direct, hypervelocity impact can create the kind of shockwave needed. And the proof for that impact? It comes from a tiny microscopic witness, the mineral zircon. You can think of it as a natural black box, one that records extreme events.
Deep inside the glass, scientists discovered zircon grains that held the ghost of a mineral called Reidite. See, Reidite is what zircon becomes under incredible pressure. It quickly changes back, but it leaves behind a kind of structural fingerprint, proof that it was there. This is our smoking gun.
Right, that mineralogical fingerprint is irrefutable. It's forensic proof that a high-pressure shockwave tore through this material. And that, well, that only happens in a ground impact. The zircon proves the glass wasn't just melted, it was shocked.
So, this leaves us with the big, critical question. If there was an impact, where on Earth is the crater?
Well, the thing is, this glass was formed 29 million years ago. We're not just looking for a crime scene, we're looking for an ancient one.
Over that immense amount of time, a massive geological timescale, any crater would have been worn down by the elements or just buried deep beneath the Sahara's constantly shifting dunes. So the fact that we can't see a crater isn't evidence against an impact, it's really just evidence of time.
So why does solving a 29-million-year-old mystery matter today? Well, because the answer has direct consequences for how we think about modern planetary defense.
You know, the threat models that are used by agencies like NASA have to be based on solid geological evidence. I mean, our predictions for what might happen in the future really depend on us getting the past right.
And that's the thing. The Libyan desert glass was once considered the #1 piece of evidence for these catastrophic surface-melting airbursts. This one single sample was propping up an entire threat model. By proving this glass actually came from an impact, this research totally invalidates it as evidence for those extreme airbursts. And that's crucial. It means our models might be overestimating the danger from some airbursts and underestimating the need to track the objects that can actually survive and hit the ground. This lets us refocus our resources on correctly modeling the real hazards of ground impacts and, of course, tracking the near-Earth objects that cause them. It's all about refining the target. So the question now is, what else needs re-examining? Because what this case really proves is that getting the forensic analysis of these ancient events right, well, that's the ground truth we absolutely need to protect our future.
Every deep dive we take here at the Deep Dive Curiosity Vault is fueled by your curiosity. If this investigation gave you a new perspective today, please hit the like button. It helps our vault reach more explorers like you. Subscribe to join our next mission by clicking the icon on the screen and check out our most recent investigation right here. As we continue to uncover the hidden truths of our world, stay curious.